Alright, welcome back. So today we're going to be looking at Cisco networking. So I want to do a video on networking. We're using Packet Tracer for Cisco stuff, but pretty much, if you know how to use Cisco, you can pretty much use them all. They're all pretty much the same thing. And Cisco is going to be the majority of what you see for routers, switches, things like that. And I want to do a video on this because I think that one of the prerequisites to hacking should be networking. You should be able to, maybe not totally configure a router, totally configure a switch into that, but you should understand what's happening behind the scenes, right, of everything. So right here I have a Cisco 2811, a 2960 Catalyst switch. Okay, this is all Packet Tracer, all free, and 3 different laptops. I already renamed them to VLAN 10, 20, and 30, and then a server up here. So we're gonna start this off, right, and we'll do a we're just going to start this off with a quick, we'll look at the router, we'll make some router on a stick, we'll do probably like an EIGRP statement to another router, to another network and everything like that. But for right now, let's do router on a stick, DHCP, and then have them be able to pull some web, we'll make this guy a web server, or something like that. It's something real easy like that, right? So let's go ahead and get in the router first. We'll go to the command line interface, right? I don't think I can actually make this any bigger, but would you like to enter initial configurations? It's going to be no. Let's go ahead and go to attributes, see if we can make this guy bigger. Big physical, big CLI, not really, huh? And that's not really doing much for us. What if we have that always on top and do something like that? We put him on top and then we hit this guy. Nope, that's not going to do anything for us either. So I don't think we're going to be able to get this thing bigger, but you should be able to see what's going on with everything. So we'll do an enable in the beginning, configure terminal, so conf t. Alright, and then from here we're going to go ahead and do router on a stick. So to do router on a stick, very first thing we want to know is what interface is going toward our LAN, right? So our local area network. So this is going to be our local area network, and the interface that's going toward that is going to be, now obviously in real life you'll be able to, you plugged it in, you'll be able to look behind it or whatever, but it looks like fast Ethernet 00. So we can go to interface F0/0, and we're going to go ahead and do a no shut. Now when we do that no shut, you'll notice that the light turns green. That is because by default routers come, their interfaces are turned off. Alright, switches interfaces are on. So these guys are no shut, these guys are shut for routers. When you no shut it, that opens up the interface and it'll at least turn green. At least says, hey, yeah, there's something at the other side. You might be able to passing traffic, but there's something over there, right? So let's go ahead and do a start to make our router on a stick. We're going to do interface F00, and then we're going to give it a sub interface, such as in .10. Alright, we'll hit enter, and we now have a sub interface. We do not have a VLAN number yet. That is just sub interface.10. We can make it VLAN 10, but right now that's just sub interface VLAN or sub interface 10. So let's go ahead and make a VLAN encapsulation .1q10. Now we have just made VLAN 10. All right. From here, what we can do is we can give it the IP address of, let's say 192.168. We'll say 10.0, 255.255.255.0. That's not going to work because it's the default router's IP address. So we'll say 10.1. Alright. And it's going to be a /24. So 255.255.255.0. You alright? Done for tonight? Alright. So we'll go ahead and do that. And then we don't have to no shut because our actual interface F00 is no shut. Go ahead and go into interface F0/0.20. IP address is going to be 192.168.20.1. And this is not going to let me do that because I don't have it on VLAN yet. Encapsulation .1q20. Same thing, we'll make this one 20.1. And then we'll go ahead and do an interface F0/0.30. And from here we'll do encapsulation .1q30, making that VLAN ID of 30, and then we'll do IP address, and we'll say, hey, this could be 30.1. So if I do a do show run here, we now have, oh, you're good. We now have 3 interfaces, all right, all sub interfaces, and this is right here is router on stick. Now the reason they have sub interfaces is because let's look at back in the day. Back in the day, they were not able to make sub interfaces, and if we had different VLANs, so if we had phones, computers, let's say you had management, HR, you know, whoever else, operations, you know. From there, you then had printers, you then had servers. So for each one of those things, you would have to add more and more interfaces on the router, right? And then you would have to buy more and more routers. So that kind of became a pain. So that's where sub interfaces came into play, right, is to be able to reduce the cost of the equipment that we're going to be using. So now that those 3 sub interfaces are all set up, let's go ahead and set up. We'll do DHCP on the router. This is going to be real simple. Usually you have a DHCP server, but for right now we'll do it on the router. We'll look at DHCP on servers later. So we'll go ahead and we'll type in IP DHCP pool, and we have to name it something. We say, let's say VLAN 10. Okay, we'll name it VLAN 10. All right. From here we'll do a network, which is 192.168.10.0. That's going to be our network address, right? 255.5.0, and then we'll do default router, which is 192.168.10.1, and then we'll say DNS server. We'll just say 8888, and in real life, if you're doing this, you can do an 8844 or something like that, whatever you want to put as your secondary. Packet tracer you cannot. Okay, so that will be your secondary right there for your DNS server. Packet tracer you can only put in 1. That's okay, whatever. All right, let's go ahead and head over and do IP DHCP pool VLAN 20, and we'll do that same thing. Network 192.168.20.0, 255.5.0, default router 192.168.20.1, and DNS server, same exact thing, 8888. Now we'll go ahead and do an IP DHCP pool VLAN 30. Same exact information, just everything's going to be 30 now, right? 30.1 for default router, the network's going to be 30.0, and our DNS server is going to be 8888. Alright, there we are. Right now, for the LAN side at least, with router on stick, we're pretty much done with the router. We haven't done anything with SSH. We haven't done any of that stuff yet. Maybe we'll go through like additional configs or whatever. That depends on if you guys want me to or whatever else. But as of right now, we are pretty much done within the router. We can get these guys at least talking to each other. So let's go ahead and hop into the switch. We'll say, hey router, you're not going to always be on top. We want to exit him out of here. Go to command line interface, and let's go ahead and do an enable, configure terminal, and now we're within the switch, right? So we have VLAN 10, 20, and 30. Looks like VLAN 10 is on interface F04. 20 is probably going to be on 3, and 30 is probably going to be on 2. Yeah. Alright, so it looks like we're going low to high here. Alright, so let's go ahead and go into interface F0/1 first, which is going to be connected to the router. And we're going to make that guy a switch port mode trunk. That's because he's connected to the router. Everything else is going to be an access port, but this one is going to be a trunk port. So we're going to go ahead and do a switch port mode trunk. Alright. And there we go. Okay. From here, you could tag VLANs, a switch port trunk, allow VLANs, and things like that. But that's going deeper in than what, you know, we're going to look at right now. Now we can look at interface F0/2, switch port mode access, because that's an access VLAN. Switch port access VLAN, whatever VLAN is on, 30. F02 is on VLAN 30, right? So switch port access VLAN, what number of VLAN is it? 30. Okay? And that's going to give you this little access VLAN does not exist, creating VLAN 30. So now's a good time to type in interface VLAN 30, and let's type in VLAN 30. Now, the reason I did that is because some of the older switches do not automatically bring VLAN 30 up, even though you just said that, hey, this computer is going to be VLAN 30, and it obviously sees something on the other side of it, right? That doesn't mean it brings it up. So that's kind of annoying. So if you type in interface VLAN 30, you can make sure that VLAN 30 actually changes its state to up, because you will be sitting there troubleshooting that link for a very long time, and it's all because you didn't type in interface VLAN 30. So now let's go ahead and go into, that was interface F02. So interface F03 is VLAN 20. So we'll do a switch port mode access, switch port access VLAN 20, and then we'll do interface F03, or F04, excuse me, which is going to be VLAN 10, switch port mode access, switch port access VLAN 10. And then from here we're going to type in interface VLAN 10 and interface VLAN 20. There we are. Alright, we can go ahead and fast forward this a little bit. And we should be, technically, we can now talk to everything. We can now, all these guys talk to each other. They can go up to the router and come back down to VLAN 30. And I'm going to show what does that look like. What does a different VLAN actually look like, right? Let's see if we can. Let's go into VLAN 10. Let's see, first off, is he going to pull an IP address? If he pulls that IP address, we know he's talking to the router, right? So let's go ahead and find out. We'll go to DHCP, and we'll see, and he does. And he pulls the correct IP address. Okay, so he pulled 10.2. Default gateway is 10.1. Let's go ahead and see if this guy decided to pull an IP address or not. Do DHCP for VLAN 20, 20.2, 20.1, looking good. And lastly, VLAN 30 over here. Now remember, in real life, obviously it doesn't pop up like that. It's not that nice. We would have to go to the desktop terminal or desktop command prompt, and we type in IP address. It's not IP config. It's IP. Yeah, IP config, not IS config. And then we do an IP config /all. Maybe we would see this like right here, right? So there we go. Okay, we do an aircrack-ng, and there's no ARP entries found. We'll look at that here in a little bit also. So now everyone has an IP address. That means they should all be able to ping each other, right? Let's go ahead and go into command prompt, and we'll try to ping 192.168.10.2. And it takes a minute. What the heck's happened, right? If we fast forward it, the first one fails. And then they all go through. Why is that? The first one fails because of ARP. Then they all go through. Okay, that's why that happens. Alright, so we got to do an address resolution protocol, then they all go through. So we can actually show this in VLAN 20. So let's go ahead and go into simulation mode. At least I hope I can show it, since I already did a ping. We'll go ahead and we'll send a simple PDU from VLAN 20 to VLAN 10. So there's our simple PDU, right? We'll press forward. It comes up and it's looking for an ARP request. So it goes to that switch. That switch then sends it up to the router. Says, hey, do you know anything about this? Comes back down to the switch again. The switch fires it off to VLAN 20 saying, hey, we figured out like where this guy's at. We're going to send you back up. Alright, and now we can go ahead and send that ping request. Now you notice we have to go to the router to send that ping request. That is because we are on different VLANs. So we are on different, according to the router, we're on totally different local area networks. According to the switch, we're on totally different local area networks. It's just a virtual local area network. Now he has to go back up to the router and back down to VLAN 20 again. And that is how VLANs work. So VLAN 20 to talk to VLAN 10 has to talk to the router. Alright, now what happens when we're in the same VLAN? So let's make another VLAN 20. Or actually, let's make another VLAN 30 because we saw that one guy fail, right? So we'll say VLAN 31. Okay? Because we saw that first one fail due to ARP. We'll go ahead and throw him in there. And we have F05. So let's go ahead and hop into interface F0/5. Switch port mode access. Switch port access VLAN 30. Alright, cool. So that guy's now on there, right? And let's go ahead and see what happens here. So let's have VLAN 30 now talk to VLAN 30 up here. Now he may still, first one may still because of ARP. Let's first get this guy an IP address, huh? DHCP, we can actually watch the whole DHCP thing happen here. There we go. We can actually click on this yellow packet like right here. This is actually to show us, hey, we got DHCP packet. Looking for any server, quad zeros, right? Hey, are you DHCP? No, you're not DHCP. Are you DHCP? No. Oh, but you are. Cool. Okay, yeah, cool. I found my DHCP, guys. What's next? What's next? And this is what I like about packet tracers, all that stuff. I think it's pretty cool. This flag right here. Alright, coming back down, guys. Heads up, heads up. Coming back down. There we go. Hey, everybody. this guy's going to go ahead and become, geez Louise, there we go. Alright, DHCP taking forever. Alright, so let's go ahead and see if he pulled that address. He did. 192.168.30.3. Alright, and we'll go back to simulation. Let's go ahead and send a simple PDU from laptop 31 to 30, which is on the same VLAN, right? So we'll go ahead and send that off. Boom. These dark green is what we're watching here. And there we are. Alright. He's going to go across. And what's this? We never left, it looks like, layer 2. Huh. We never left layer 2 because we already have, the switch is already built. It's MAC table. So we already understand that these two guys' MAC addresses are the same exact thing, are within the same VLAN. Right? So now we can go ahead and ping them all day and not have to go to the router because we're within the same local area network, within that same VLAN. And there we are. And we're done pinging them. And we pretty much never left layer 2. We never even went to layer 3. It's just showing layer 3 here because we did actually ping from 30.2 to 30.3. And we did the ICMP message. But he never had to go to the router one single time, right? Look over here. The only thing that went to the router was, let's see here. There's 10. There's VLAN 30. There's switch. That's why VLAN 30. VLAN 31, VLAN 30. See how he never actually went to the router here? VLAN 30. See? Never goes to the router. So now we can go ahead also, and let's check out that ARP table for VLAN 30. Do an ARP-tac-A. And sure enough, when you know that, we have 30.3 and 30.1. So it knows about the router, okay, and it also knows about this switch, or this computer down here. So he knows about both of those things. Right? Awesome. Now, if we were penetration testers, we can now see, okay, looking at this guy's ARP table, we can see, ooh, he knows about two different people. 30.1, most likely is going to be the router. 30.3, okay, that's probably another user. We can look at the physical address, right? So the MAC address, and figure out maybe what type of computer it is. Who made the network interface card? Was it Dell? Was it, anyone like that? HP or whoever else? We could see maybe if we could figure that out, right? We could also see type is dynamic, okay? So that's going to say, hey, how the heck did he get that IP address, all right? Or static. So we'll know, hey, if it's static, it might be something important. Right? It might be something that, we might want to look into because that's something that the IP address they never want to change. They never want the IP address to change. That could be something like a prayer, like some low-hanging fruit like that. That could be maybe the CEO. That could be some servers, whatever else. So now we have all that set up. Let's go ahead and set up our 8888, right? Our DNS server. We'll go ahead and go to desktop. We'll go to terminal, we'll go to IP configuration. We'll make this guy static. We're going to say, hey, you're 8888. With a 255.255.0, doesn't really matter. Default gateway is going to be 8881. You don't have a DNS server. Exit out of there, and there we go. So now we made that guy, right? Let's go ahead and make start default gateway was 8881. That means that this interface F01 is going to be 8881. So let's go ahead and get into here, enable, configure terminal, and we'll go ahead and we'll do an interface F01, IP address of 8881, 255.255.0, and no shut, and we can see that that line has now come up. Let's go ahead and try ping 8881, or excuse me, do ping 8888. First one fails because of ARP, or it failed because I'm a jerk. Yep, first one failed because of ARP, and then there we go, our next 5 comes through. We don't need to do that ARP request again because it's now in our CAM or our MAC table, whatever we want to call it. And there we are. Okay. So we can now ping him, right? He is a web server. Okay. We can actually say, hey, your services are going to be HTTP. That's on. HTTPS is on. We can turn DHCP on if we want to. Right now it's off. We'll show that later on. But now we can now get to the internet. So we can go into our guys here, go to web browser, and we can web browse to 8888. And we get our Cisco packet tracer, a small page, hello world, copyrights, okay. You can mess with your friends and come in here. You can actually change what these things say. Is that right? So hello world, we can edit that. We can, like, I don't know, we can marquee. I don't know if we can do like a body BG color or anything like that. BG color equals black. Font color equals pink. Then we can type in down here, welcome to Prawn Hub. We don't want to get sued by the other people. There we go. Then we can try to end the marquee. End marquee, end font, end body, end marquee. There we go. Okay, and we'll go ahead and save that. There's already file's name. We'll write it yes, and we'll go ahead and see what we get with that. Okay. We'll see if we go back into here. We go back into our web browser. We type in 8888. And then there we go. Welcome to Prawn Hub. Okay. So you can mess with your friends wherever you want to do. All right, but yeah. So we can now talk to that server, right? Everyone can talk to him. Okay, every single person can. So we can go 8888. And there we are. We can also do HTTPS 88, and there we are. Okay, so we're good. So everyone can talk to that guy. V910 can talk to him. Everybody. So we're now going from our LAN to our WAN network, right? PS 88. Boom. Cool. Awesome. All right. So there is a quick down and dirty programming router on a stick to a switch, and then connecting a few different VLANs, looking at the ARP, the things like that. So we can actually look at, should actually be able to look at the CAM table in here. Should be show, not port security, MAC address table, MAC address table, and there we go. There's our CAM table, like right there. All right, so if you're ever able to get into a switch, you can also see everything like that. You can see port security, anything like that that's set up. Now, something to note, that if port security is set up and it's set up with like a MAC address sticky, you can spoof your MAC address and it will work. So port security will not catch if you have spoofed a MAC address. On my old YouTube channel, I actually showed that, but now we got taken down by YouTube. So there's all this stuff, like right there. Let's go ahead and let's now look at EIGRP, what type of information that sends, and if we had an internal network that had multiple connections to EIGRP, what that would actually look like, right? So I already did this. I already made this router. So on the physical, there's already another 4 Ethernet cards on here, Ethernet ports. To do that, all you have to do is shut it off, and then take one of these guys, drag it over, boom, boom, and then turn it back on. Okay, just so you guys know. Here's a little zoom in, shut off, grab like 4E, drag it over to here, bam, and then you just turn it back on, and there you go. That's how you do that. So let's go ahead and set up another router now. So we'll throw a router into here, 2811 again, boom, or we use 2911, whatever you want to use. We're not going to go with multi-layer switches or anything like that just yet, but we'll do something like that. Okay, obviously it's going to be crossover cable, although nowadays it actually won't be, because most likely we have, what is that, auto crossover, auto MDIX. So we got Ethernet 1.0 to fast Ethernet 0.0. So let's go ahead and make a link between those two. Command line interface. We'll go ahead and we will actually delete. I have an idea. What we're going to do is we're actually going to delete that server. And then we're going to go ahead and we're going to throw that server right over here. And we'll connect it from our router to there. And then this one will be 8888. Okay? That's what we'll do. Alright. And then we'll show how they talk. So let's go ahead and hop into Ethernet 1.0, I believe it was. Yep, Ethernet 1.0. So we'll do a interface E1/0. And from here, we're going to go ahead and make an IP address. So something that will talk between those two. So let's do an IP address of 10.111.255.252. Then we're going to do router, EIGRP, and then the autonomous system number. If you're getting this far, you should know what the autonomous system number is. It's a number that each EIGRP network is going to use to be able to talk to each other. We'll just say our EIGRP number is 10. All right. we're going to do network, and it's going to be 10.111.110. And now we can either put in the wildcard mask, or we could put in just the IP address, which will then be changed, or the subnet mask, which will then be changed to the wildcard mask. So we'll go ahead and we'll start off first with wildcard mask 0003. Okay. Network, what else do I own, right? 192.168.10.0. And we can go ahead and put in subnet mask time. Okay. This time we'll do a wildcard mask 000255. And lastly, we'll go ahead and we'll do a subnet mask again. And I also own network 30. So I know network 10, 20, and 30. As you can see, I put in different things here. Right, we have our subnet mask that we're supposed to have on our interface, but then from there we put in a wildcard mask, subnet mask, wildcard mask, subnet mask. Now if I do a do show run, you'll see on EIGRP they will all be wildcard masks. As you see right here, that's a wildcard mask. These guys right here aren't going to show anything because it's auto summaries now, so let's go ahead and do a no auto summary. And they're still not showing anything. Usually you'll see that 000255 after this. We should be able to see it, but Packet Tracer does some weird stuff, so that's whatever. So on your actual physical gear, you'll most likely see 000255 afterwards. Okay, so interface E1/0, and we'll do a no shut. That change state to up. As you can see, it's still down because the other router still is down to that guy. So let's go ahead and hop into that other router, and we'll make him yes. Now you did know, oh crap, no. No. That was the worst idea ever. No. Oh god. Okay. Thank God. So you'll notice I did not say that 8888 belonged to us at all, right? Let's go ahead and enable, config T, and we'll go into interface now. F00, interface F0/0, no shut. IP address is going to be 10.112.255.255.252. Notice that they fell into the same network, right? This guy over here, Ethernet 10 was 10.111. Ethernet fast Ethernet 00 is 10.112. 255.255.255.252. 255.255.255.252. From here we can do a router EIGRP 10. Remember, that was the atomic system number for this router over here. And we'll go ahead and do a network 10.110.00003, and we should see that we have a new neighbor, okay, or a new adjacency. Alright, now if I do a do show IP route, I should learn about all these other guys within this router right here, and that's how, there we go, I do. And as you can see, there's a D there. D means that I learned it through EIGRP. Alright, so that is how EIGRP actually works. So this guy's telling him about the different links that he knows about, and if I kept going to the EIGRP, they would just continue to learn from each other. So I learned about 192.168.10.0/24 via, so from, right, 10.1.1.1.1, which is this interface right here, which is this router right here. Awesome. Gateway of last resort is not set. I can show you what the gateway of last resort is. We can do it for this guy over here, this interface, saying that, hey, anything we do not know about, we're going to send that way. We just want to get rid of it. We don't care where it goes, but we don't want it, right? So let's go ahead and we'll do that. All right, so I still will not say anything about 8888 existing. So we do need to still put that, hey, we are 8881 over here. So interface, God bless you, that's 01. And we're going to do an IP address of 888.1. 255.255.255.0. We do a no shut over there. Alright. So we did our no shut. And right now, this router, because this is not an EIGRP, 8888, still does not know about it. So we can go into this router, like right here, show. And he still does not know. Do show IP route. He still does not know about any 888 network. Correct? So let's go ahead and hop back into this router. If I do a do show IP route over here, we do know about it, but since we have not put it into EIGRP 10, router 0 does not know that that exists. So let's go ahead and go into our server here, and we can say, hey, you are going to be HTTP again. Our desktop, we'll make you 8888 again. Subnet mask 255.255.0.8881, and there we go. Okay. Now let's go ahead and set up that gateway of last resort. So we're going to type in, we're going to hit exit. We're going to be back at just this config prompt right here. We're going to type in IP route 0000 Now we can either send this to a next hop or an interface. Okay. Usually you want to send it to a next hop, but this time we're going to send it to an interface, which is going to be interface F01. So we're going to say F01. So now if I go into EIGRP and I redistribute static, now type in redistribute static, he's now going to redistribute any static route that I have, which is this guy right here, because he is a static route. I do not suggest to do this on a large network, especially if you just got there, okay? Because you can redistribute static and you can end up taking down the whole network, redistribute static, and somebody else is trying to do it, and you will create routing loops. All right, so if I go to do show IP route now, we do have a gateway of last resort. It's quad zeros to network quad 0. Okay, we don't need to worry about that. But this guy over here also learned about that gateway of last resort. Right now it's not set. As you can see, we do an IP route and do show IP route. And we do have a gateway of last resort is 10.1.1.2 to network quad zeros. So he knows about it because he's redistributing it, right, this router. So his next hop from here is this guy right here, which is 10.1.1.2. So that's how we know that. And we also learned about that externally. So we learned about that EIGRP to an external EIGRP of that quad zeros via 10.1.1.2. Because really our interface is going to be over here, right? That we're sending all of that information. So that would be external to this interface over here, which would be for him to get there, and then he has to pull the information from that interface and say, okay, cool, that's why it's external. Cool. Alright, now from here, we can go ahead and we can try to ping 8888. Do ping, sorry about that. I told you guys we're in the very beginning that if we're in the config, we're going to type in do every single time. First one should fail because of ARP, and then we should get the rest should be successes. We do it again, there we go. So technically, even though nobody else knows that 8888 exists, as you can see, that's not in here anywhere, right? It's not in our EIGRP statement anywhere, right? So he hasn't learned about it. So even though no one knows that exists, because of that default route, that gateway of last resort, we should be able to ping it and get to it from a computer, which we can. He can ping it, which if he can ping it, that usually means we could probably open it up, right? Usually. Don't always think that. So we'll come in here, we'll go to our web browser, we'll do it 8888, and sure enough, we get there. Easy day. And let's go ahead and do that on one of the other VLANs, and we'll do it for HTTPS traffic. And it still works. Awesome, cool. Alright, so we have now done router on stick. We have showed EIGRP statements. We have done a default route to a server. We have shown how to do a VLAN real quick on a switch. And then we have got those computers talking to each other, shown the MAC address tables on the different computers and everything, and also on the switch. So for penetration testing wise, I don't really see going much deeper than that, unless you're going to be learning about the layer 1 through 7. Like, people do not teach stupid people acronyms, unless you're going to be learning something like that. I don't really see it going much further than this, unless you're using something like Yersinia and you're actually doing Cisco hacking, which if you're doing something like that, this could be more of a specialized, test, and you should understand, have it be well versed in Cisco equipment at that point. I mean, if you guys have any questions, let me know. If you guys want to see more videos like this, where maybe we can go over switchboard port security, we can go over pulling DHCP from another from another server that's outside of your network, IP DHCP forwarding, things like that. We can go over all that stuff if you guys want to. But yeah, if you guys want to do things like that, let me know. But that right there should be about it for penetration testing, with just understanding a network and understanding, what type of what the different devices do, how they're talking to each other, things like that. Now there's also OSPF that we could have been using. There is RIP version 2. There's a bunch of different routing protocols that could be used. I decided just to go with Cisco or EIGRP, because that's the one that I utilize the most in the environment that I work in. Alright, so you guys have a good evening, and I will talk to you all another time.